Hello guys, my name is Desmond and I welcome you to my lesson for today. Ladies and gentlemen, please do allow me to say it's very much important, ladies and gentlemen, that I say it's very much important, because what I'm about to say is massively important. Guys, a day without learning something new, it's a day wasted. So guys, for today's lesson we'll be looking at Physical Sciences paper 1. This is an exam paper of November 2015. So guys, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Okay, massively important, ladies and gentlemen. So guys, obviously, as I've indicated, Physical Sciences paper 1, exam paper of November 2015. So good people, just in case if you're watching this lesson from my YouTube channel, please do make sure to subscribe so that you don't miss my upcoming lessons. And most importantly, click on the bell notification to be notified of every time when I upload a new lesson. So guys, you are advised to start each question on a new page. Okay, so for today's lesson we'll be looking at question number 3. Massively important, ladies and gentlemen, that you pay full attention, because with this type of lessons I'm only guiding you in terms of how you would approach this type of questions. Okay, so ladies and gentlemen, I'm just going to quickly read through that given statement, and then from there we'll have a look at the questions. So ladies and gentlemen, our first not necessarily our first question, but the given statement reads as follows: ball A is projected vertically upwards at a velocity of 16 meters per second from the ground. Ignore the effects of air resistance. Use the ground as zero reference. Very much important, ladies and gentlemen. So in this case, you're given a statement where they are talking about ball A, which is projected vertically upwards, ladies and gentlemen, at that velocity, which means you've got V initial of an object which is projected vertically upwards, whereby an assumption of positive being upwards can be made. Remember guys, a sign of a positive or negative only refers to the direction. Okay, so just in case, let's say you've got positive 4 meters per second or negative 4 meters per second, do not compare the magnitudes or the two values to say this is a smaller velocity compared to that one. Guys, be careful of that. Remember, I've just said a sign only refers to the direction. A sign only refers to the direction, which means an object could be traveling vertically upwards at a speed of positive 4. It's the same velocity as an object being projected vertically downwards at a speed of negative 4. Okay, so that negative, it only refers to the direction. Okay, it doesn't mean a negative 4, it's a smaller velocity compared to that. It's the same velocity but in different directions. Okay, be careful of that. So that's what I'm saying. For this type of a question, ladies and gentlemen, we can just assume 16 meters per second to be a positive velocity since it's traveling upwards, so it's being projected vertically upwards. What is the reference, ladies and gentlemen? From the ground, which means that ball A is being projected vertically upwards from the ground. Okay, massively important, ladies and gentlemen. So now they say ignore the effects of air resistance, and most importantly, use the ground as zero reference. Okay, so now I think we can go to the questions. But before we do that, ladies and gentlemen, let's have a look at what other information is given down there. So can you see? Let's just confirm if that is the last question. Of course, this is 3.3 is the last question. So can you see? They are now talking about that ball A, which is being projected vertically upwards at that speed. So that means the V initial of ball A at 16 meters per second is projected vertically upwards from the ground, where upward direction can be assumed to be a positive value for object A. Okay, which means for object A, G is not in the positive direction, but it's in the negative direction. Okay, why? Because we assumed upwards to be positive, and we know obviously G, it's actually acting towards the center of the earth, or otherwise always downwards. Okay, ladies and gentlemen, I assume you fully understand that part. So the initial statement did not say anything about object B. Obviously, as we continue with our questions, there might be somewhere where they talk about object B. But for now, we are concentrating on object A at that speed, using the ground as zero reference, okay, or as the reference point. So ladies and gentlemen, let's go back to question number 1. So remember guys, you first need to understand the whole of that statement, okay? And at all times, all the given information, it's exactly what you need in order to answer the question. So you need to use the given information together with your basic knowledge to answer upcoming questions. So now, question 3.1. The question says, calculate the time taken by ball A to return to the ground. Massively important, ladies and gentlemen. Guys, what is the cream of that question? Calculate the time. Ladies and gentlemen, time is the most important thing that you need to consider when answering that question. Why? It's because in the end, you must say time is equals to whatever calculated in seconds. Massively important, ladies and gentlemen. Remember guys, in physical sciences, time is measured in seconds, okay? Do not give anything else other than time, which is in seconds, okay? So guys, now you need to know time under which conditions. So guys, they say calculate the time taken by ball A to return to the ground. You see, to return to the ground. This forms part of the cream of the question, because you need to know what time you're calculating. So in short, remember, this is the ground, right? This object is projected vertically upwards, ladies and gentlemen, with its initial velocity being 16 meters per second. Okay, so this is your V initial, and obviously as it goes up, there's that negative G of 9.8. okay, obviously, ladies and gentlemen, this object is going to go up, reach its maximum height, and return to the ground. Massively important, ladies and gentlemen. We know that at its maximum height, its V, of which can be referred to as V final, is equals to 0 meters per second. Massively important, ladies and gentlemen. So remember guys, I do teach a complete or a full lesson where I take you through all that you need to know in relation to vertical projectile motion, ladies and gentlemen. So that lesson contains all the info that you need to know regarding this chapter. So if you go to my website, www.solvingexampapers.co.za, That's where you will find those lessons under grade 12 physical sciences. So there should be a tab on your top right corner where you can click there. You will see you've got grade 12. You click there, physical sciences, and then under that tab of physical sciences you should be able to find all the lessons about this chapter, ladies and gentlemen. So now you need only 3 quantities, ladies and gentlemen. You need only 3 quantities in order to calculate the 4th unknown quantity. Okay, you need to understand that part, ladies and gentlemen. So guys, do we have the quantities that we need? And answer to that question is yes. Why? Because we've got number 1, initial velocity, number 2, final velocity, number 3, gravitational accelerator or force of a gravitational acceleration, or what is it, gravity, acceleration as a result of gravity. Okay, so we need to calculate the time taken by this object to reach its maximum height. Okay, we know that time taken by the object to reach its maximum height is the same time the object takes to reach the ground of the position where it was initially projected vertically upwards. So guys, if it takes 2 seconds for it to reach maximum height, it's going to take 2 seconds for it to reach that level or the ground from where it was projected. So that means we can just calculate time taken by the object to reach its maximum height. Whatever time that we get, let's say is 2, we just multiply it by 2. Okay, why multiplying it by 2? Because it's up and down. You understand? So ladies and gentlemen, in case if it takes 8 seconds for it to reach its maximum height, you just multiply it by 2. Why? Because it's 2 trips. For it to go up, it takes 8 seconds. For it to come down, takes 8 seconds. Okay, which means for that ball B to go up, ladies and gentlemen, and come down, it takes 2 times of the time it takes for it to go up. I hope you fully understand that part, ladies and gentlemen. Okay, so guys, let me just remove all of that information. There's a question that I want to answer, ladies and gentlemen, in one of the lessons that I had in my WhatsApp. Remember guys, I do conduct WhatsApp lessons. I'm sorry guys, I think I had a bit of an issue there, but I was saying you might find that the lessons that I conduct, it's 3 times or 4 times, 5 times a week. It all depends on the schedule for that week. So ladies and gentlemen, obviously you do have an idea of how to solve for that question. Okay, please do make sure that at all times you show all the necessary steps. Okay, massively important, ladies and gentlemen. So now let's move to question 3.2, where they say sketch a velocity time graph for ball A. Massively important, ladies and gentlemen. Sketch a velocity time graph for ball A. Okay, what does it mean? It means you must have a graph showing the velocity versus time. Okay, in brackets you must show that it's in meters per second. Okay, and then time is measured in seconds. Massively important, ladies and gentlemen. The other most important thing in this case that you need to show, guys, it's the following. Show the following on the graph. We want to see initial velocity of ball A. We want to see time taken to reach the highest point of the motion. Ladies and gentlemen, we want to see time taken to return to the ground. Okay, so let me just quickly give you an idea of how your graph might need to look like. Obviously, you've got your y-axis, which represents velocity. Ladies and gentlemen, in brackets, it's in meters per second. Okay, so now you need to also have the x-axis, which shows time, in brackets, it's in seconds. Okay, remember guys, if we assume upwards to be positive, then that initial velocity will be on that side, which is 16 meters per second. Remember, it's a positive 16 meters per second. Okay, massively important, ladies and gentlemen. So obviously we've got zero velocity there, and on this side at the bottom we've got negative 16 meters per second. Okay, so in terms of the time, ladies and gentlemen, let's just assume that it was 2 seconds. Okay, let's just assume that it was 2 seconds. Obviously one is somewhere there, then here it's going to be 3, here it's going to be 4. So we know that if it takes 2 seconds for it to go up, it will still take 2 seconds still to return to the ground. Okay, so now, ladies and gentlemen, that point there where the time is 2, this is when this object reaches its maximum height, this ball A, and it takes another 2 seconds, ladies and gentlemen. It takes another 2 seconds, 1, 2 seconds for it to return to the ground. Okay, so now obviously when you draw your graph, you just connect the lines. Obviously its velocity started at 16 meters per second. Okay, so you cannot have your graph in that direction, because it seems as if as this object goes up, its velocity increase. Okay, whereas it doesn't increase. That's why you've got your graph in that direction, ladies and gentlemen. You just connect those lines. Why is it in that direction? It's because as time goes on, the velocity decreases until it reaches 0 after 2 seconds. Does it make sense, ladies and gentlemen? Then the reason why you need to extend that graph in that direction is because obviously after reaching its maximum height, where its velocity is 0, ladies and gentlemen, its velocity start to increase, but in the opposite direction. Does it make sense, ladies and gentlemen? In the opposite direction. Okay, so it continues to increase up until it takes another 2 seconds to hit the ground, which means it's going to hit the ground at that same velocity. I'm not sure if it makes sense, ladies and gentlemen, but I assume you fully understand, because I've given a bit of background regarding this type of questions, ladies and gentlemen, regarding this chapter. So I assume you fully understand how you will represent your graph. But most importantly, we want to see the initial velocity of ball A. Most importantly, we want to see the time taken to reach the maximum height. Most importantly, we want to see the time taken to return to the ground. Okay, massively important, ladies and gentlemen, that you show all of that information. So guys, let's now move on to the next question. So before we get to question 3.3, as you can see over there, we are given a statement. So ladies and gentlemen, it reads as follows: 1 second after ball A is projected upwards, a second ball, which is ball B, is thrown vertically downwards. Massively important, ladies and gentlemen, it is thrown, not released or not dropped, but thrown vertically downwards at a velocity of that. So that means for ball B, ladies and gentlemen, we've got initial velocity for ball B, which is 9 meters per second. Okay, so guys, you can assume the downwards direction for ball B to be positive, which means also the gravitational acceleration will be a positive, because both are in the same direction. Okay, so it doesn't mean because you chose upwards as positive for object A, then the same applies for object B. Remember, B has got its own motion and its own values. Okay, so you can now decide which directions to use for object or ball B. Massively important, ladies and gentlemen. Okay, so now let's continue to read that given information. So they're saying obviously is thrown vertically downwards at a velocity of that from a balcony 30 meters above the ground. Refer to the diagram below. So remember, guys, it is still the same ground where object A was thrown or projected vertically upwards. Okay, massively important, ladies and gentlemen. So I hope you fully understand that information because all is represented on the graph. So ladies and gentlemen, I think we can now move to a question 3.3, which is allocated a lot of marks, ladies and gentlemen. It's allocated 6 marks, if you're able to see over there. It's a lot of marks, ladies and gentlemen. Please do make sure that you score all of these marks. Okay, so guys, let's read the question. The question says, calculate how high. Guys, cream of the question, how high? So that means in the end, you might need to say change in y is equals to whatever in meters. Massively important, ladies and gentlemen. In physical sciences, we measure the height in meters per se. The height in meters. Okay, that is the SI unit, the international symbol unit for measuring the height. It's in meters. Okay, so in the end, you must say change in y is equals to, or height is equals to whatever calculated in meters. So they're saying how high, calculate how high above the ground will above the ground ball A will be at the instant where ball A will be at the instant the two balls pass each other. What an interesting question, ladies and gentlemen. Remember, this ball A is going upwards, isn't it? At some point, let's say this is now ball A, right? At some point, ladies and gentlemen, ball A and ball B are going to pass each other, ladies and gentlemen, at some point. So remember, 1 second later after this ball A was projected vertically upwards, this one is also thrown vertically downwards. Okay, so obviously guys, at some point these two objects are going to cross with each other. Okay, so the question wants to know that height. They want to know what is that height at the instant object A and object B passes each other. Okay, very, very much important, ladies and gentlemen. So you might need to do some calculations for object B and do some calculations for object A, and compare the two, or somehow perform some calculations where you do some equations in order to find out the height. Okay, massively important, ladies and gentlemen. That's why this question is allocated 6 marks. So I will spare this question for when I do it in one of my lessons. Otherwise, ladies and gentlemen, if you're not able to join that lesson, let's say for example you notice or you watch this lesson weeks, months or years after it was done, and you were not able to join my WhatsApp lesson where I solve this problem, please try to check it out under live lessons on my website. It should be there, because normally I do this type of questions under exam revisions, and then from there I'm still going to solve these problems, so that in case if you missed my WhatsApp lesson, then you can still catch up. So ladies and gentlemen, I hope you enjoyed this lesson as much as I did. And guys, I think this is that time where I need to sign out. So ladies and gentlemen, thanks very much for joining. My name is Desmond, and I'm out.